Alright, thanks for coming along to our June presentation night. This night had its genesis at the WIA virtual conference, where Kim was going into quite a bit, and in fact had quite a few photos of the Aurora in dry dock in Singapore, and I at that point thought this would be a good expanded talk. So that sent Kim into a frenzy. Not I have no doubt.
I suggested, no, it wasn't actually, it was because that was a bit of a practice, so that was quite okay. I don't think I have one photo of a penguin. I have about 3 photos inside the ship and one of the trawl deck, and that's it, I think. So yeah, you've had your ship quota.
So over to Kim.
Okay, right. So yes, Kim Briggs. We all know who I am, and I know who I am, so it's pretty good. My memory hasn't totally failed me yet. So that's what Justin says, very true. That's sort of how this came about, and plus he didn't have everybody for June, so that's another good reason for doing it tonight. So what we'll talk about is some techniques that have been developed, some by CSIRO, some internationally, and some by AAD. Most of this is AAD. So what is here, sort of, this collection in front of me is just SeaCom connectors. They're underwater connectors, and I'll just talk about those for a second. But this particular beast up here, which doesn't have the strobe inside it because it blew up, is a stainless steel strobe that's been manufactured at the instrument workshop at the Div. I can't remember who machined this. It's Staino, rated for 2,500 metres. So it's quite happy to operate at that depth. So the fundamental thing is, with electronics you're going to put in the ocean, it's a bit like your ship. You want to keep the water on the outside, or your radio gear, you prefer not to mix the electricity and the salt water. So it's the same story. If you flood something with salt water, you can, and it hasn't been turned on, you can potentially wash it out, and it will work for a little while, and then it always dies. Nothing ever recovers from salt water because the salt just gets inside everything, and things start to corrode, and you know it's goodbye Charlie. So to join everything up, you use these underwater connectors, and these are SeaCom brand ones, which we use. There's a few different brands, and they come in different shapes and sizes. I can't get this one apart, I need to heat it up, but it's a reasonable size. It's about the same size as that one there, so it's about maybe 20 conductors. All of the pins are gold plated, and I can't even do it up. The base of the pin has got a rubber sleeve around it. Can you see that? That little rubber sleeve?
Yes. Oh, yeah.
Okay, so the idea is that when you join them together, that rubber sleeve goes inside that rubber housing, and the pins are further in. So you use a Dow Corning product, DC4, just to lube up all the edges of the not the pins, of the actual housing. And so when they go together, they slide together quite nicely. Let's see if I have one apart. There we go.
Wow.
So there's one apart. And do they mate? Yes, they do mate, I think. Can't see my alignment. So they go together like that. So as they go together, one lot of rubber goes inside the other rubber. And they go together. And then you clamp them up tight with the housing. But the really good thing about them is, as they go down in the water and the pressure comes on, that outer sleeve gets pushed over the shroud that's around the inside of the pin. So they clamp up really tight. And when they come apart, they go bonk and pop. So like I could put a couple of you on either end of that one, they wouldn't come apart. Expensive? Yeah, just a bit. A combination like that's probably close to $2,000 at the moment. These ones are about, not that dear, $150 each. They normally come with a 450mm tail, about that length, and you join them up. We'll talk about joining them up in a little while. You always buy a tail longer than you need by a bit, so if you do have to re-terminate them, you can keep chopping the cable back. If you buy it too short, you can only chop it off once, then you've blown the connector. So you try and plan ahead a little bit. but fantastic connectors. They will work down to, the deepest we're using was probably about 5,000 metres.
Holy crap.
Yeah, so it's deep water stuff. Yeah, this is offshore science, oil, gas, those sorts of industries. And I'm going to show you some photos later of something I saw in the wharf one day. When they screw in and they've got an O-ring on the face. So everything's about pressure. It's all about holding the air in and the water out. So if the water can't get in, the air doesn't come out. The air comes out, the water goes in. And they're all bulkhead fittings. So that's called a bulkhead fitting. And this cap here is a female cap over the male pins, like over those pins. And you'll often have a situation where instrumentation gets changed around between the bodies. So you'll have one, and we'll see this in the photos in a minute, there's like one central controlling unit and everything fans out off that. And so as you change your instrumentation around or your function around, you'll want to disable those sets of connectors. And the way you do it is with one of these caps and the appropriate size sleeve goes over the top and screws up, and they're held together. So they're both held together mechanically so they can't come apart in case it gets snagged, and they're held together for protection of the electrical contact. So talking about, if I keep clearing them out, and there's just some different styles. If I keep clearing them away, that way it'll be pretty good. And often when you're calibrating something, you may need to get signals out, so you can make test leads with those. And this particular one is off a smaller CTD. These are quite clever. So what you've got there is all of these connectors that are like a pie, and they go into they plug into the appropriate circular female socket, and so you load them up. Now these are all blanks, so these are for just sealing up, and except for that one because it's got cables on it. So you'll change the configuration of what you want for the function that you're doing, and then when you've got your configuration right, down comes the outer cap over the hole. The two halves bolt together is fine. So it's high reliability. It's designed to be reused, which is often the two don't necessarily go together, and they seal really, really well, and they allow you flexibility in what you're doing. So these are a SeaCom too. I can't remember what type they are, but they're quite big. The same thing, it says it's got a 450 tail, and there's the flanking ones. If you want to have a look at any of this stuff later, be my guest. So we can get rid of that because we don't need that, and we can leave that, and we probably don't need those.
Are the connectors available for general use, or are they
if you've got enough
under
dollars.
contractor? Yeah.
If you've got enough dollars. Yeah, there's probably, I don't know, have a guess, Kim, $2-3 grand to replace those ones in there. You know, they are high-end connectors. But we will talk about connectors for amateurs, because one of the things I want to try and introduce tonight is how we can benefit out of the techniques that the industry is using. So what we have up here, can we flick these lights off please? The overhead lights. So what we have up here is a beam trawl. And this, I had a business for about 15 years and I'd sold it, and Mary says I was hanging around at home, which I wasn't really. And anyway, the Div advertised a job in marine science. I went, oh, that's interesting, because I'd done a bit for them about 15 years before, 20 years before, back in the Nella Dan days. And so I thought, oh yeah, and I applied, and I ended up with a job. And what we were doing was actually setting up a system, and there was this project called CMARC, which was the Census of Antarctic, Marine, blah, 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 everything underwater and everything in the water column. And so I ended up working with the E-Lab for a while, with Alan and co. Alan's 7KAJ, is that correct?
Yes.
Yeah, okay, that's a good guess.
Who's in Kununurra at the moment?
Yes. And so we were there. So what we've got here is a beam trawl. This trawl runs along the bottom of the ocean, just like a sled, and it's dragged along by the ship at about half a knot. Now, the gear that you can see, I didn't bring my pointer, is a series of lights. There's 4 lights on it. So the narrow floodlight is this one here, and they're LED lights, and they're mounted on an aluminium substrate. The aluminium substrate's a slip fit inside the aluminium housing of the lamp, so you don't need a heatsink, because the whole lamp is a heatsink, and you're in water at about -2 degrees.
Yeah.
So that's not an issue.
Hey, perfect.
Oh, beauty. I hope they're not CMOS.
Well, if they were, not anymore.
They're inside a protector. So video camera in the middle, video camera, and that's the video camera out of the housing. This is an early one. There's lasers there, the narrow flood lamps. So the narrow flood lamps look are quite tight. We can see this in some of the images. These ones are floods that spread out further, and in these tubes here are the battery packs, and it was all totally self-contained. We set a timer up on it. It would go over the side to get lowered down to the bottom, and it would come on at its own time. You know, we knew roughly how long it takes to get to the bottom, and then based on how quickly the cable was going out, that was hanging on, and the depth of the water. And so as it went down, it would sit at about that attitude as the ship's moving forward, because the net out the back, which is like a big trawl net, would act as a drogue, and underneath it, you'll see in a minute, there is a green mat, which is an anti-wear mat. So if I go down, page down or down?
Page down.
Yep.
Oh,
Okay,
it's just
what'd you do?
taken a while. Sideways.
Okay, fair enough, sideways for down. This is just out off the east coast. There's a ship in the background, and the water's too blue for Antarctica. So this is the other version, which is using that strobe and that stills camera, which I'll show you in a minute. So everything was interchangeable. We could swap over in about 20 minutes, half an hour. But we had two systems, because it was far better to use two different systems rather than swap over, because you have to get all your alignments organised. Again, same battery packs, and there was some battery capacity in there as well. The strobes, the camera, which is in there, I'll show you in a sec. It's a Canon SLR. This is circa 2007. The strobes were Canon off-the-shelf strobes running in the container, running dry. CSIRO had developed that system, and we adapted off it. It was controlled by a Tiny Tiger. Both systems had Tiny Tigers, which were a nice little, you can't call it a pick, it's one with
Raspberry Pi almost.
well, yeah, it's a computer in a box,
Yeah.
basically, and you run BASIC on it. So it was quite a high-level computer to start. They were about $100 each then, and we used them for quite a few applications. And they were firing the strobes through a solid-state relay. One thing you may have noticed with all of this gear, this is another thing I found in the shed when I was searching the other day. It's for another project. There's a lot of this equipment's round, like it's cylindrical. So the things that you put in the ocean are cylindrical or they're spherical, like a buoy. And the reason that's really simple, it's compression, it's pressure. So this is the stills camera. That's in an aluminium housing.
Wow.
This is in an aluminium housing. And so the actual mechanical design, Pete DeVries built these. I think this is part of the Cyro design adapted by Pete. The actual components of it provide bulkheads inside the cylinder. So they reinforce the cylinder, because a cylinder is like a beam. The ends are the strongest and the beam curves. So if you put bulkheads in the cylinder, you allow it to take a higher pressure.
Yep.
So that's the concept behind that, and also the bigger the moment of the bigger the level for compression. And that's a bit of old electronics, underwater electronics from an American company, EG&G. I don't actually know what it does. I found it in the bin. But have a look at it, because it's all analog, and each board has its own function. So there's like an A to D board and blah, blah, blah board. So this is the stills camera system, which is running the strobes. The video camera system was running the floodlights. The floodlights ran continuously because it was video. The strobes were fired by the camera. Okay, too far back. Try that one.
So, Kim, was the camera programmed in such a way just to keep taking photos?
Yeah, we could change the settings before we fired over the side.
Yeah.
Hang on, let me go back. No, we're going forward now. These are underwater camera shots. No. How do we end up there? Let's go back. Okay, here we are, back where we were. Good. Okay, so strobe. The SCAMR depth sensor is basically a radar for underwater, and it just pings down and it tells you how far off the bottom you are. So it lets you know what's going on, which is good. So there's the camera. That is another pinger for looking down, for measuring depth off the bottom. the camera body there, and it was all quick changes. Bolster up here and there's adjusters there, you can put it around, scan motor over there. And there's one of these strobes looking straight down, and as you can see the SeaCom connector on top. We had a couple of different configurations depending on what we were doing, but that's the basic configuration.
That's serious engineering.
Oh yeah, it's serious. It is serious. I wouldn't even hesitate what it would cost.
That creativity deserves a pay rise.
Me, I did the electronics and put these things together. That's the trawl net. You can see the scan motor up there, and so this is the back. And this whole thing would weigh heavy, close to a tonne. And it was running on about a 22mm cable off the back of the ship. So yeah, you've got this on the bottom, and you've got 10,000 tonnes rough enough of ship on the front chugging it along. So there were times when we pulled the ship up actually one day and we got stuck against a bit of a cliff underwater. And there it is going over the side, out through the chute, and there it's an Australis photo. There's two in a row. And that's the strobe. Now, when we did some really long transects from shallow water out into 2,000 metres. The limit for this was 2,500. Just to take a photo every, I don't think it was every 10, I think it was every 30 seconds. So it was like about a 2-hour drag, so there was a lot of photographs. And we found we were getting black images because the strobes weren't firing. The strobes just couldn't keep up with the recharge rate. And so we had to look at a few options. So we used this system over a couple of years, a few voyages. So one of the solutions put up by the ELAB was to fill them up with oil. And that sort of worked for a while, but then the oil got into all the capacitors and all the other components, and it went even more unreliable. So the simple solution would have been to just keep changing the strobes, run a strobe for 1,000 shots or something or other and throw it away and put a new one in. But considering that it was commercial equipment off the shelf, put into an industrial application, and the camera getting dragged along the bottom, I think we had 2 cameras fail and basically just mechanically fell apart. They just couldn't cope, but I wouldn't like to be dragged along the bottom either. Be a bit scary. And that's a sequence of shots. So it was afternoon tea for the guys. We didn't have the lasers on, obviously. The lasers were bright enough that you couldn't use them without laser glasses, so we had to be a bit careful. This is just an image of the trawl deck for focusing purposes, and you can see the cable there with a swivel in the middle.
So, sorry, what function did the lasers have in the...
Oh, I'll get to the second.
Sorry.
That's all right.
Sorry, Kim.
Okay, now this, we also used it in a vertical mode and a horizontal mode. So if we were using it on the bottom of the CTD, which I'll show you in a second, you were looking straight down. So we did, we might have done 120 CTD drops. And so we thought every time it goes down, we can take photos with that. It'd be quite good. We'll get a cross record, like a correlation between seabed and where we were in terms of latitude and longitude. But the problem was that the ship's a ship, and the CTD hangs out here, and the ship rolls. And so you lower it down, and you really have to be fairly close to the bottom. And if the ship rolls the wrong way and you're close to the bottom, you're in the bottom. And if the image is taken as you roll away, you're out of focus. Mm-hmm. And so we sort of persevered, and we needed a means of knowing how big the object was on the bottom that we were looking at, because it's like looking at the moon, you have no idea. And that was something said to me today about rocks from a distance on the moon. You just don't realise how big they are when you look through your telescope, and it's exactly like this here. So by having 2 lasers pointing down 450 apart, then we had a rough measurement, but we didn't have any depth, so we probably should have had a 3rd laser going across at 45 degrees, maybe intersecting 2 metres out.
Yeah. And
from that then we could have scaled, but because of the problems with it rising and falling, so there's another thing. You see the 2 laser dots?
Yeah.
So that they're parallel, and they're about 450 apart, so that's pretty close to the bottom. And also when you got higher you couldn't see them. So going back, that's what we were getting out of the stills, out of the bottom off the CTD. It was really variable quality and it wasn't worth pursuing for the amount of effort involved, and you only got about 2 minutes of bottom time when you could use it, and part of that was the ship. If there was any sea was on, the ship was rolling, wasn't usable anyway, so it sort of went into the good idea of a bad application type thing. So this is coming across to trawling. You can see the shadows of the trawl wires. And that's strobes. That's the two strobes firing out. This is seabed. So that's taken from about the height of the camera, as we saw in the photos earlier, about that high above the seabed. And that's not bad. The quality varies a bit depending on the conditions and how silty it was, but that's a usable image. There's another one, and these look like plants, but they're all animals because we're down a couple of thousand metres. There's no sun, there's no photosynthesis, so these are all animals, even though they look like plants, which is in itself a bit strange to sort of contemplate. And you can see the chains going up to the trawl cable.
So the sled was being dragged over the top of that.
Yeah, and that's another point of contention in a minute. So there's bottom there.
Oh yeah, there's
Footprints.
Yeah.
And
been there.
I could bore you all night with these thousands of those photos, but I didn't. That's the propeller and the rudder. So that would be taken with a flash, but it's just natural light basically. Then of course the trawl gathers up everything that goes into the mouth of the trawl, and so you end up with a big bag of critters. And the science crew on board, we had a considerable number of science people there. They'd then go through and sort out all of the specimens and put them into classifications, and then they'd go off around the world after the ship came back to Hobart and the stuff had gone through quarantine, and they'd then go to the experts around the world that dealt particularly with those types of animals and sorted them through. So we, basically every time we did a trawl, we generated new life forms for that area because it had never been, that was why it's a census that had never been done before. But the problem is, to get all that stuff up, you've run a trawl across the bottom, and so you've left kilometres, 3 metres wide of turned over ground.
Yeah.
And so the question was, would we ever do it again? And the answer was no. So we did a couple of events like that, but this was the primary one.
But presume that would recover reasonably quickly?
Maybe not.
Okay.
What's it called? Bioremediation. I did a voyage later with a guy called Andrew Constable, and he was a div person, but he was representing for Australia on CAMELA, which is the Confederation of the Conservation of Antarctic Marine Living Resources. Thank you. And I had that discussion with him one night. I was sitting around having a cup of coffee, and so we'd done all this work setting the ship up as a longliner, would you believe? And we had a camera system in a long tube on the long line to try and work out how the long line interacted with the bottom. And so we'd spent a lot of work on that. It cost a fair bit of money in ship time. Anyway, after about 3 or 4 days, he said, that's it, let's go. We're going over there further west. And I said, so Andrew, we've done all this work. What's your story? He says, it's like this, Kim. He said, I only get this ship for 10 days every 5 years. I've got enough information. He said, we found rubbish on the bottom, which means there's been humans in this area, probably fishing. We've seen parallel lines that were made by rollers on the bottom of the net. That indicates there's been fishing. He said, we've seen drag lines, which could well have been long lines. That indicates there's been fishing. He said, now this area is closed. I don't know when that was done. He said, I now take all your images back and give it to the benthic, the seabed experts, and they'll come back to me and say, they'll look at the like the trench made from a roller or the drag marks from a chain, and they'll be able to calculate how quickly the surface has been turned over. And so by looking at what's living there and the characteristics of the holes they make in the seabed or whatever, then they can determine how long ago that activity took place. And if it's a long time ago when the activity was allowed because it was open, that's fine. But if it's more recent, they've got poachers. And so he said, that's all I need to know. And he said, so we move on, so now we're going to do somewhere else. Okay, CTD. It's an abbreviation for conductivity, temperature and depth. Depth's pretty straightforward. There's a cylinder down underneath that's got all of the sensors in it. These bottles are called Niskin bottles, and they've been around since the very, very early days of oceanography. In the top here, there's a release mechanism. It's all titanium. And what you've got, and we can see it in the later photos better, you've got a cap on the top and a cap on the bottom. They're all lowered in empty, and so the water flushes through. And you fire down the cable, there's a section cable over there, I'll show you in a minute. You fire down the cable and it fires the latch releases top and bottom, the caps come down and you capture the water in there. And then you can bring water samples back from whatever depth you fire it at. So you can go, normally you'd float it close to the bottom, maybe 20 metres off, get one there and you'd come up every few hundred metres or whatever. They go down to about a metre a second, they come up at about the same speed. The full weight of that is around a tonne.
Wow.
And it's on this cable, which is, as you can see, only 7 or so millimetres. It's double layer spiral steel. It's really tough steel, and up the centre is a single conductor. So all of the data comes up through that conductor, and all of the control signals goes down through the conductor. And of course, the cable has to be longer than the deepest water you're operating in, and our deepest water is about 5,200 metres around off Cape Leeuwin in the southwest of West Australia. So you have maybe 6,500 metres on the drum. There are 2 drums on board, and the idea is that every time you take it off at the end of the season, you chop the cable off. The top section of the cable is the one that really gets hammered when the carousel's coming out of the water, and if there's any swell on, the loads go on and off. About a tonne, rough enough, when it's coming out of the water. So if the ship's rolling or there's any swell, it goes from being supported by the water to instantaneous loads. It's not a good time, so you just chop it off. So that way it allows you over the years to knock your 50 metres or 100 metres off, and you're underway. Now, before we get on to this, I should show you this camera. Both of these cameras. So this is the, actually, if you want to flick the lights up, please, Justin. Thanks. It is tiny. Now, everything's designed for quick turnaround. That's
Battery pack.
a battery pack for the camera, and there's the firing mechanism for the strobe in the side there jammed in. We're using wide-angle Canon lenses, just on fixed focus,
Yep.
and that was why the photos of the trawl deck were there, so that we could work out what our focal length was. Tiny Tiger sandwiched in behind, in behind there, and there's another board in behind which has got the firing mechanism. Oh, it's on the other side there. Cyclone batteries. Some of you may have seen them in emergency exit alarms. There's a tube of them in those typically. You can hammer them really hard. They charge quite well. Look, these ones went in September 2010. They were never replaced. Just great batteries. They're really tough. Now, the housing for this was bigger than the housing for that, with a bigger window, and that housing seems to have disappeared. So we could do things easily. You slid the housing in. The ring and the O-rings provided you with the guide, and there's 2 plugs plugging out there. In the back of the housing, there's the female version, and so you just turn it around. It says top, which is top. You get it in, you'd line up, and you go, yeah, that's the top, because there's a label on the actual housing itself, and then you go ka-chunko, and it's in, it's done. So to take it in and out was like literally a few seconds work, which meant that we could take it out, we could do work to it, or we could put it on the charger or charge those batteries up, or whatever we had to do really quickly. And so again, the circular case, so that's a DC 5-volt DC converter. But the whole thing is along that lines, so it works a treat. Now, see how it rolls? It's a problem at sea. So, and it's also a problem, the trawl deck's often slopping around with water. So what we just do is into a mini fish bin, there's your carry, and it stops it rolling around, nice and easy. When you had a lot of stuff in the lab, which we did, just build stocks, everything sits in stocks, it's there, it's carry, it's easy to work on, do whatever. There's another advantage too, that when you look at a fish bin, that stock fits straight into a fish bin. So that's your transport as well, and the cables and everything all go in together, so you know you've got the system. And when you're finished with the equipment, you know that fits in there, so you fill up with fresh water, and you can drop it in, and that becomes a bath for it, so you can have things washing. So it's all about sort of taking the minimum you need to take, but doing the job with as many ways as you can. And that's, just strap it down, that's fine. You'll travel quite happily. So that's the stills camera. It's quite neat, nice package, and no superfluous space, and they work like an absolute treat. So then we have, I'll just keep moving these the other way so we can have a bit of a look. Video camera. This one, I haven't got the bottom screw. In fact, I don't think this is the camera that was in it, I think that's another one. 9-volt batteries for basic power to keep things going. The Handycam, they were fairly low res in their day. I don't know what this was.
CRB50.
Yeah, 1.5 megs. Effective still 1.39, but we could fire stills out of them, or we could fire video. Card straight, onto a. I think these were tape actually. Were they a card?
Yeah, that would be tape.
That's tape, yeah. Okay.
But they also do. You with your sodium memory stick?
Yeah.
That's what they used to take.
Okay, right.
I've actually got that camera.
Yeah, there you go. Look, I reckon yours is embedded in this one. And you can set the time up for the delay for starting. We also used pressure starts too as well, but mainly the timing on work best. And so there it is there. And if we look inside this one, so open it up. Which way? We're going to go that way. Can go. So there's your camera in there. There's no screws. Straight out, there's your camera. So you can do whatever you like, and it's away. And again, the same thing in the back. The connectors are in the back there, and there's the power. Now, the things on the lens, isn't it? So what is it? O-rings for seals. So everything is O-ringed, and 2 O-rings, a bit of DC4. The accompanying grease is perfect. It'll seal. You know, you keep it clean, no grip, no nothing, and they work a treat. Again, O-rings are really well engineered because they've got to have just the right amount of squish. Now that's compression of the air in there.
How thick's the glass on the front?
About 20 mil, 25 mil. Yeah. But, yeah. Well, the pressure. It's flat. See, that's the trouble. It's not curved. It's flat.
Yeah.
The strobes are curved. They're only about 12 mil. And those ones there, I can't remember. They look about 20 mil. Yeah. So that's that. Again,
presumably when it's going down, obviously the O-ring seal is also being squished, so it's improving the seal.
well, if the housing collapses on it, but it's just they take the pressure on all the way, as long as the water doesn't get in your phone.
Are the housings commercially available? Or
No,
it's debated at the moment?
Oh, mate. I suppose Pete or Chris or one of those guys machined them up and we sent them away, got anodised. That was done before I started on this project. The same thing with the lamps. The lamps, they're individual leads, they're on that alloy substrate, and so the whole lamp becomes a heat sink. In the back, you've got a SeaCom, and they were running on 28 volts. Now, to get the power for them, I actually didn't bring the lid in. These are recycled Andera current meter cases that came, I think, from Cyro, and Pete cut and sharpened and I put a section in. And what you've got inside, battery pack.
Excellent.
Yeah, I know. So there's 4 lots. They all come out to there. We had KDEX 4-channel chargers, so you just came inside when you wanted to run through the charger, which was after each deployment. You come in, plug them in the KDEX, press the button, all 4 channels, just charge them. So we could charge them, I think it's about 45 minutes, 50 minutes.
Holy crap.
Yeah, so they warm up, but they work really well on cold waters. Again, same story, quick and easy. The lid comes onto this, it's got a handle so you can carry it by it, which I left in the back of the car, I think. And it had cam locks by the side that grab it onto there. An O-ring comes into this ring here, so as it comes on, it squishes harder. So it's slightly different to those. It's a face O-ring, single O-ring, and they were a bit of a limiting factor because I think they were the weakest link out of all the housings. But we had them because they were the right size and we could get the batteries in we needed. Tony Vaness was involved with this. Tony's in Holland these days, but he did a lot of the engineering in conjunction with the electronics workshop and most of it at the instrument workshop. But yeah, like really neat, really easy. And it's got a number in the back, 3667. So yeah, and so then they laid either side of the trawl. So they're in that tube on the side, that's where the batteries live. So they were this high, flip the lid up, had a couple of gate hinges on it, or gate locks on it, flip it up, whip them out, walk inside, give them a rinse off. Well, unplug them of course, walk inside, give them a rinse off, and out they came and off you went. It's really neat. And that had to be because you were doing virtually continuous deployments. So
what sort of time would that give you? What sort of battery duration, battery life here? Are you talking hours? Or?
Oh yeah. Like if we were doing longer stuff, hours. Depends, how much you've got on and whether you're running all the lights or whatever. But heaps of time. And we never ran them fully down. The water temperature is about 2, so those batteries tolerate that quite happily. -2, I should say. I'm thinking negative. I'm not thinking positive.
Yeah.
But they just worked a treat, and the batteries are like $30 each, so they're relatively cheap.
Yeah.
And so you can recharge those when they're cold, but you can't recharge lithiums below 0, really, -2, -3.
Wet cells.
They're a lead acid cell.
Yeah.
They're spiral cell, I think.
Yeah.
I'm not sure, I can't remember. So we could hammer them, and they worked really well. Because the other thing too was, if you were doing something and there was a change to the weather or a change to the situation, you might suddenly discover you're not about to deploy, and so the ambient temperature could be -5, -10, -12, and these would be sitting out inside a steel housing, inside stainless steel tubes, and so they start to cool down pretty quickly. So you could actually grab them, take them inside, or if you knew it was only for an hour, you just leave them and they'd be fine.
Yeah.
They'd warm back up to sea temperature when they got back out there. Because they'd go in, they'd be a bit warm when they went in, which gave you that sort of degree of latitude. Yeah, so that's sort of that area of it. What do I miss? Anything? No, not really. But you have a look at the end stack there, because it's an interesting earlier version of oceanography, oceanographic electronics. And I looked at a couple of date stamps. I think it's probably late 70s maybe.
Wow.
Okay, so CTD. This is CTD. You've heard about some of the gear that goes in it. I'll see if I can show you some of it. So again, if you... Oh, can we have the lights off, please? You can see the strings, the bubbles on them. And can you see the caps are kicked up? There's another one too. And there's caps on the bottom. So the caps are open top and bottom, or they're like that. Not like that. So that's how they flush through, and that's just on the way down. 25, 30 knots on that day.
It looks a bit rough.
So looking down, this is inside the CTD frame. This white frame is aluminium, and it's not tubular because it's compressed. It's all solid bar, so it's about 40mm bar. It's all American. Don't ask what it's worth. It's something ridiculous. The one on the right hand side there is a downward looking pinger. This is one of the strobes, and that's the back of the strobe with the SeaCom connector and the two halves joining it up. And so it's looking down. So this was the system in the CTD frame that was okay as long as it was at the right focal length.
So that's one of those, is that right?
Yeah, that's one of those. And there's the stills camera, which is in the housing down. It's in the other housing. It's down there below. And as you can see, up is down. It makes sense when you take it out. And that's the aluminium frame of the rosette. This is a crappy rosette photograph because it's a bit out of focus. And if you're looking at the colour of it, which is normally white, that's a sunset photo or a sunrise photo. But you can see, and this is a trial because there's no bottles on it. All the bottles have been taken off. I reckon this is probably the east coast of Tassie, and you can see the downward-looking camera over there in this stainless frame and the connectors on top. And the actual CTD instrument is laying through there. See a sort of grey instrument laying through? It's about that long and about that around, about 100 grand. Yeah, it's serious stuff. And there's another bottom photo that we've taken with the CTD. There's a fish in that one, I think, somewhere.
Lasers as well.
Yeah, and there's the bottles. Now, this is in the room where the CTD is stored normally, and the door opens inside the ship, and out they go. Now you can see how the lids are cocked with the strings, and the strings come back to the central mechanism that holds each of the strings, and you can sequentially fire them. So how they're fired is because of the length of the cable, you're putting about 280 volts, I think it is from memory, plus or minus a bit, into the cable, because you've got to put it in on deck before the winch, and it goes down through slip rings, through the winch, through all the wire on the drum, and eventually gets to this. So to power this up, you've got to start with a much higher voltage drop, by squared up. Sorry, it's not just power. But think about that, IR, is voltage drop. Anyway, so that's all fine and it works all very nicely. But because the signals from the CTD, like the temperature and the conductivity, all those signals are coming back up that cable, it's a bit of a contradiction to say that you're actually firing the rosette from the top. So what they do is reverse the polarity. And so it's effectively gated off, and then it fires the rosette. And you just fire one each time, and the mechanism rotates around in increments by one bottle at a time. And you can run 24 bottles, except we had the upward-looking sounder and the downward-looking sounder, so we lost the bottle. And occasionally you want to take, for the bios, the marine bios, you want to take a bigger volume, and that's just another rosette that we had on board with massive bottles. I think they were like 50 or 60 litre bottles. And they're insulated as well. All the bottles have got insulated walls, so that when they come back on deck you can actually get the water out and do the series of sampling without it coming up to inboard the ship temperature, which in the CTD rooms not much above ambient. Now, one day I had a job to do on a Russian ship that was down here, and this is at Hobart Port, out on Macquarie Point.
You can see the tower.
Yeah, into the tower. It was a really yucky day, and it was a love job on a Saturday. The guy said take a half an hour. I was there all day helping him out. Anyway, I'd been on the ship doing this stuff, and as I was walking along, I saw this yellow container, 40-footer. And I went, that's pretty weird. And I looked at it and it said, RPOS, Canadian submersible. And that sort of attracted my attention. I went, hello, what's this? I thought, gee, I wonder where the submersible is. And I'd walked past it. I don't know what I was doing. I'd actually walked past it. And this is the submersible. So, as you can see, it's as tall as me. I would not have any idea what it's worth. But it's got thrusters in every corner and all hydraulically driven. And there's Niskin bottles in there, and that's all bits and pieces. Hydraulics everywhere. It's just amazing. And there's the Niskin bottles for sampling water. You can see a couple in here, and there's a couple laying over there. And everywhere you look, it's just jam-packed inside this frame with thrusters and mechanical arms for going out. It's like something out of science fiction. So it's real bottom of the harbour stuff. Fantastic. And there's all the cameras, and it's got pingers looking up and pingers looking down, and it was on. And it was like a non-profit. Some guy decided he wanted to do oceanography and had hired the ship and recruited all these people, and they're going around the world and they're going to Antarctica. I don't know the full background of it, never heard or seen anything about it again. But you sort of go, wow, that's pretty amazing. Now, how we were talking earlier about the blanking plugs? Right, if you look here, this says Science JC. JC, JB? JB, junction box. Science junction box. Now off the bottom here you can see cables going in, it's a bit hard to see. But see these ones where they go nowhere? They're the plugs. So that's how you can configure the whole thing up and put it into sensors that you want to do. So so the system is really simple. Look, there's a SeaCom there, there's some instrument, there's a couple of SeaComs there. This is industry standard. This thing would be the sort of stuff you'd use for inspecting, I don't know, underwater cables or oil rigs or something. It's a serious bit of gear, and it probably weighed, I don't know, a ton or something. I don't know. It's just chock-a-block, and it's like hydraulic motors, hydraulic rams, hydraulically driven thrusters. Yeah, pretty amazing bit of gear. Quite impressed.
Holy moly.
Yeah, I know. Just like,
Wouldn't you hate it if the hydraulic failed halfway through the bottom of the water?
or you lost your string, no longer attached. I don't know whether it was fully remote or whether it was actually operated, tethered, and didn't actually find the information out. This is a whale listener. Some of you will have seen this image before. They come in from the States, and we've got whale guys, and they'll run down to about 1,800 metres, I think, and you lower them down to the bottom. They sit on the bottom and they record whale sounds, and they're good for 2 years from memory. And in here is a lump of steel each end, and that wire there is a fusing wire. So they've got battery packs to run the electronics, and when you want to release them, you come over the top of the ships. Theoretically, you know where they are. You write the Latin long down, mark the point on the plotter, and you hit a code. So each one's got an individual code. You fire the code in, the pinger on the bottom of the ship pings it with that code, and it'll respond, then you know it's alive, which is always a good day, and you're over it. And then you'll put in the fire code, and the fire code puts the battery power through the fusible links. The fusible links go open circuit, the weights fall off, and it comes back to the surface. There's a couple of tricks, because the ocean's stratified and you get different thermal layers in the ocean. You can be sometimes sitting over it and you have to ping it for quite a while before you actually get it to respond, because the signal's getting attenuated, just like ionospheric variations. And then the other thing is, because it comes up... Sorry? Ducting, exactly.
Oceanic
ducting.
Yeah. I know you're there, but I can't see you.
Because it's whizzing off over there.
Yeah, or whatever, who knows, or there's a submarine sitting over it. Anyway, the yellow covers, spherical buoys, strongest buoys, glass buoys in there. So that's your buoyancy. And they come up like really, really, really slow. And of course, because you've got currents in the water column, you basically get everybody on deck and say, watch for this thing, and they only float with about that much of the lid up, like they're hard to find, and every time I've been involved we've got them back We did have one once that didn't want to talk to us, so we just left it. It's still there.
Do you ever get them that actually come up under the boat and snipe the
No,
boat?
that'd be an interesting one, wouldn't it? just move the ship forward. We'll see if we can see it. Chomp, chomp, chomp.
Just on that, Kim, have you ever lost any CTDs?
No, but I know people that have.
Oh, jeez.
Yeah.
String failure
I can't remember. A failure, doesn't matter.
Yeah.
Well, ultimately the string must have broken.
Yeah.
Yeah,
Ouch.
no longer attached, and that's one getting deployed. Yeah. Oh, if you throw it over the side of the ship, you've got to assume you lose it. That's the bottom rule of marine science. Yeah. There's one going down. Yeah, so quite neat. This is an American project that was on board. And this is an array of gear that has the things in the background with a tripod sort of frame over the top. They sat on the bottom, and all these other things went up through the water column. And those are actually glass buoys to provide support for all of the gear that was hung down below. So they had a series of acoustic sensors, say it correctly, Kim, and the wire they were suspended on was something like 600 or 800 metres long, and they had other instruments that actually walked up and down the wire like koalas going up and down a post, doing sampling at different levels. But this is another one that was a bit problematic. They'd done a firmware upgrade on the crawlers some months before, and the guy that did them, I don't know him, I've never met him, said, yeah, it's all fine, it'll work perfectly, and not all of them worked. Only some of them went up and down. The other ones stayed stationary for the year. So yeah, that was so look, look, every industry has its failures. Every industry has its bonuses. But I think anything that you do in the ocean and you get back is is quite remarkable. One of the labs on Australis. There's another Australis photo for you. Pretty typical of the labs. Always really crowded because there's so many people working in there. Gear everywhere, and all this gear comes out at the end of the voyage. In a few days, because the ship's got to go and do its next voyage. So it normally takes you longer to set it up than take it out.
I like the sign on the back on one of the photos and one of the power boxes.
Yeah, do not drill here. You do need signs
Will
like
that will that be less problematic with Naina because it's owned by the div?
That's Harvey Marchant. He's a buyer. Yes and no, because Nguyen is so much bigger, there's going to be more franchising of science. Like sometimes you'll have 10 different countries represented on the ship, and so they'll bring their gear with them, and or you'll have students coming in to do support for somebody else who's they're doing PhD work supporting another project, and that might come from a university on the mainland or a university overseas. So yes and no. But always, you normally get 3 or 4 days to set the ship up before the season or before the voyage, and then you get a bit more time, to get it off. Occasionally we have to make things on the spot, and this was a turns counter for the one of the winches on deck that didn't have a turns counter. So it was a tiny tiger in a plastic bottle with a sensor and a magnet glued onto the drum.
The Hall effect sensor just to reset it?
Or reed switch or something, just whatever we could find. Or a seat, we just found what we could find. It worked. A lady came along with an ADCP, and it's an acoustic Doppler current profiler, so it sits on the bottom and looks up and measures, pings, and looks for the variation in the return ping because of the modification due to the velocity of the water. Anyway, she didn't bring enough batteries, and it was a fairly long voyage. We said, I think we can fix this, so we went and ran it around because we knew we had a heap of 9-volt cells and just wired up a heap of 9-volt cells.
Serious stuff.
Oh, I can't remember, they were serious parallel. I can't remember what the voltage you needed, but we just worked out what we needed, and it was rough as guts. But it worked. She was happy, and I think we did 2 stacks for her. She finished the voyage, but that's the difference here. They can either sit there and twiddle their thumbs going, if only, or you say, well, let's see what we can do.
Let's do
I love how you put the 9 volts together. That's hilarious.
It worked. Now, cables, here we go. This cable, which you should have a look at in a little while, if you ever have to do a join of a cable that needs to be waterproof, like say you've got an antenna controller or something and you just want to do a lash-up job, you can use these and they'll last a fair while. They're crimps, you can get them from RS and other people, and there's 3 sizes, there's green, pinky reds and blues, and each one represents a wire size. And you strip off the cable, So this is a CTD cable. So that's the return, the outer. You can see the two layers: the left-hand spiral, right-hand spiral, which is that cable there, and that's the centre conductor that the data comes back up in, and the initiation signals for firing the bollars goes down, and everything's powered through. So you crimp it up. Now there is a divider in the middle here. You just see a little indent there. There's some in the car. I'll go and grab it. So you need a set of crimping jaws that are only half width. You know, like most of the ones, they have the two crimps. You have the one that goes over the insulation and the one that goes over the connector. These only have half. So you crimp one side, and then you put your wire in the. That's looking vertically at it. You put your wire in the other side, and you crimp the other side, and then because they're heat shrinkable, they've got glue. You just heat shrink them down, and they'll seal on the conductor, and they'll last some time. So. If we're really pressed, which we have been, and we haven't got time to cure them. Now, this is something too that would also cross over an amateur radio. That's a section of heat shrink, and we have to bond from the cable going down to the CTD, which is this sort of cable, to the actual metallic cable with that single-ended conductor. So you join it up. In fact, that's what this job was. You join it up inside. You have your rubber cable, your heat shrink onto it. This is glued heat shrink. It's about probably red. 32 mil, 35 mil goes down to 12 mil. So you shrink the bottom for about 50 mil. It comes down to the cable. That gives you a waterproof seal because it's not like we're talking a waterproof seal because it's gripped onto the rubberised cable. And then we put potting compound in, which is polyurethane. Leave it taped up to whatever we've got it taped up to for 12 hours, and that will do. If it's done properly and everything's clean, that'll do a season of CTDs.
Wow.
So that's maybe 100 deployments or 140 deployments. And we also use it for a cable that's about that thick on the RMT. Gets done at the start of the season, sits on deck, does the deployments on the RMT, and you chop it off at the end of the season. They just don't fail. So if you did have to do something in the field or at home, you could use a system like that for doing it, like an antenna rotator cable, and you'd put it on so that that section was facing down. After it's cured, of course, and the bell, it comes down like a bell, come down like. Actually, I didn't do this one. They're cut off too short. We might go a bit further. No, they're all a bit short. I normally leave them up the cable for about 50 mil, 40 mil, 50 mil. So you've got a good seal, and then it comes down like a bell, and the actual potting compound is so. For radio purposes, works a treat. That's a way of doing it. Now, if we go back a bit, I have done them when you've really been pushed for time and you haven't got time to pot it with vulcanising tape. Does anybody here use vulcanising tape?
Yeah.
Okay.
Never heard of it.
Okay. That's Scotch tape. It's not cheap, but it's a rubberised tape that self-amalgamates. So.
Yeah, it's great.
So it has a plastic coating on the back, and as you stretch it by about 30 or 40%. This is a bit gungy because it's been sitting around, but as you wrap up, it actually joins onto itself and it bonds and it becomes a solid layer of rubber. And so you spiral, you start it up, put like a double layer on where you start, and then just go around. You stretch and overlap by about 50% all the way around, and you spiral down. Then you turn around and spiral back up, and you pull it in tight to the bit where you started, and hold it, and it'll grip on. And then a double layer of, I've got two of them, Scotch 33, a double layer of Scotch 33 black vinyl tape, it'll be fine. And you'll get, if you get it so there's no voids in it, if there's voids in it, the water can get in. If you get it so it's really tight and it amalgamates up, you'll get maybe 10 drops with a CTD,
Wow.
down to substantial depths.
Impressive.
A couple of thousand metres, so it's good stuff. It's a primary solution if you need to waterproof things. Now, if you had to, I don't know, I'll just think of an application.
I've used that stuff on to create naked flow pot antennas.
Yeah.
And I think the tin pod around the outside for the secondary antenna.
Yeah, catch.
The secondary antenna. I use that stuff on the outside of it. It's waterproof protection.
Now, whilst we talk connectors and waterproof connectors,
Yeah.
these are Amphenol C16s. They're a bit expensive, but you can find them. I looked today, and there's some around for $10 each. So they're the bulkhead fittings, and we'll pass those around. And these are they're multi-pin, and these are only 4-pin. 4-pin are rated to 10 amps per pin, and there's a couple of styles. They're really good because they incorporate an O-ring, and we use them on the ship outside. We use them for automatic weather stations. They just last and last. They're not affected by UV. So again, for things like antenna rotators or whatever, you screw them up and they just seal because they have O-rings into them and they seal together. But better still, if you're doing something like in field work or whatever, where you're going to disconnect and reconnect, they come with a male and female cap. So you take your cable up, put a female cap on each end, you know your cable's intact and it's going to be clean the next time we want to use it. And where your bulkheads come out, that's actually a slightly different style. Where the bulkhead comes out, you screw in the plug type cap for the bulkhead. Same story, but it's not the sort of thing you'd go and buy on a whim. But if you're actually going to build something and design it and want to know it lasts for 20 odd years or whatever, or you might have to shift it in the future, they're really, really good. So Amphenol C16s, but there are some other copies around. But like some people say $50 each, but I saw some on eBay today that were new. I'd look at home tonight, and they were $10 each. And you can get...
Where can you buy them from?
RS is one of them.
Okay.
Farnell, Element 14, or Farnell Element 14. Just look around. Amphenol C-16 multi-pin connectors. But if you think you're going to use them, just keep an eye open. Get someone who can afford some, and there's some of the cheaper prices. So bulkheads male, bulkheads female, plugs male and female, and caps and plugs. And they're all interchangeable, so if you made your cables so that the same pin was the same at each end, you could reverse your cables or whatever, because it'll be just continuous straight through, so good thing. Okay, dispersion finished, before you bore you much more. Other sort of stuff we do is, it's a portable comms package with HF and VHF marine and VHF airband, and a solar panel sitting on a power distribution box. That was an A-gap, it's a div photo. It was a project about 15 years ago. This is a repeater, Hendo I think, up above Mawson. So that's a fair way up. Fiberglass box, solar panels on two sides, and it's fairly old because I can't remember, that might be a KL repeater. Looking at their clothes. That's another, that's Berchevet. It's an island with a penguin rookery on it. It's a Kim Newbury project, and it's got Wi-Fi back to Mawson.
The solar panels that are vertical?
Yeah, that's really common.
Yeah.
Lighthouses too. They've been doing it like that for probably 30 years in Queensland because of all the bird poo. If it's vertical, it'll wash off.
Yeah.
And what they find is it's all over the ground as well, so the ground's white, it reflects, so they get just as much light bouncing onto the panels as they would if they tilted them, but if they were tilted, they'd be covered in poo pretty quickly, and it'd be a bad day.
Well, especially with the modern solar panels that don't actually need the angle.
So, and also with snow around, you've got a lot of reflected light as well. Snow is, what's the word? There's a word for reflectivity, and snow's at the top of the list, snow and ice crystals. Okay, here we go. This is 1950 odd. I've just found this old photo. Davis. Hi Mel, I'll give you a call back in the morning. Bye.
Love it.
He's one of my friends. Actually, he's a dentist, house renovator, we've known him for years. And Malcolm has got into valve radios, like out of the 30s and 40s. He knows nothing about electronics. He's learning, but it's quite amusing. So recently, the radio, there was a restoring valve radio book here from EA or Silicon Chip or something, years ago. Anyway, I took that along to Malcolm the other day. He said he'd read this. Blah blah. Okay. See the transmitter on the left hand side of the wall with the panel on the front of it? I reckon that's an ART-15, which was an aviation Collins AM transmitter, about 100 watts. And the one next to it, I think, is a Helicopter's X28, which is sort of at the end of the war. This photo is maybe 57, I think. I'd have to look at my notes. And this is a bit of a classic. So this is the telex days, which weren't really that far away for a lot of us. Some of you probably never seen telex. But if you read down, so it's VNJ, that's the station, and it's from Icebird, and now it says 2nd of February 86. I don't know what NR84 is or CK035. What position? I think so. 2306 net. It's time, and the next one's the distribution list for logs, whatever that is. Don't know that. Manning, there was a bloke there.
Successfully transformed passengers into zombies.
Yeah, OIC all stations, voyage leader and Eldan. Yeah. And then you go down a bit further. I found some old doco that came back from station, and I had to flick through it. A few of them were quite good, so I did that. So this other one's Davis again, OIC all stations, voyage leader, Iceberg
I was
Eldan.
looking at that.
Yeah.
Hobart Cup is a horse race, not a Kingston Beach pub drinking race.
Now, that's Graham. I wouldn't mind betting it's Graham Chompers Curry, who used to be VK0GC. He just went back after time and time again. He had a camper van in the States. He used to go holidaying in the States and come back and go back to Antarctica. I don't know who this Peter dude is. Yeah, but if Ellen was here, he'd probably be able to tell us. But you get that. And it was all sort of, it was all factual and everything was happening. And 13 knots, 13.5 knots at speed, 36 hours continuous rolling. So she was probably, where was she? Separate number 32. How do I decode? 5503 east, so it's 55 degrees south, that's not east, it's south, and 112.10 east. So she's well east because we're 140, whatever we are, 140. 43 or something? Okay, I remember 143 or 47. Houston was part of Australia's 150. Yeah, so she's well away. She'd be out in the South of the Indian Ocean, out there somewhere. Probably coming back from Mawson maybe. So she'd roll like a dog going downwind. Okay, so the guy who did this is Aaron, the guy on the left hand side, and the guy on his right, or on the far right is the bosun. That being trawls in behind you, see the green mat that runs on the bottom behind. So it's the top of the net wearing through. So whilst this happening, you got any questions? Make them easy.
The strobe and also the camera and the LED lighting floods. Did you have to do any filter adjustments to compensate for light traveling in the water?
No. Yeah, we had different elements to go in front of the lens and we ended up just running them all open. Basically that's the light, that's the light for the strobe or through the leaf. It's fine. So that's the bottom of the ship.
Which ship was that?
Australia.
Was it when you guys in really close calls with the vascular mapping ship?
Oh yeah, I had to try to photo last night of an upside down coming back on board. I thought I didn't want to tell you that. So that's the false rock. Yeah, that's pretty good. So it's almost like a hook-up. So as the ship pulls, and if there's any swell, the tension comes in the cable, and it will tend to lift off the bottom, which is why you're sort of going into darkness because the light comes in the bottom of the roll time. Yeah. And so the video camera has a microphone there. This is what it's actually hearing on the bottom. Some of it's going to be conductive to it. 150 metres. That's a glass sponge.
How far apart are those laser points?
About half a metre. 2 foot or so, I think, I don't know. But you've got that one. Now, a fish. Gotcha. So, a lot of these critters, actually, their structure is silicon. They extract the silicon out of the seawater, and the sponges or the sponges, they're quite tall, look like a bar, and don't actually blast. So when you get them out of the net, they spike. They actually are like glass fibre sponges. That's what it is. And these long filaments, they're made by a single cell, very small, it's single cell creatures. It's like around that filament, and just move up against crimping the circle onto that filament. And when you actually look at the filament, there's a lot of articles about once it's on the phone station. When you look at the filament, it's got like a textile outer sheath which gives it the strength and stability. But the inner core is a perfectly optical pure and fibre optic coating. And then the estimates were like, it might be 1,000 years old or something like that. There was a good discussion there about how old they were. It was those sorts of discussions that made us go, do we really want to do this? We've seen it, we've always been village that an animal TVO in custody. But yeah, it was an interesting place to do, but it's not one to do repeated. Over the edge of it, it's like, there's no bottom. And again, we go. The thing we always observe is the amount of colour we're seeing. Yeah. So that's like some of the fish over there, the fish over so you never know, how much disturbance is there? Yeah.
So I think the animal is welcome.
Yeah. So that's an animal on one of those children. So they're actual animals up the corner, up on the other animals.
Yeah.
It's like saying there's an animal on plant.
Yeah, no, that's what
I find it quite alien to sort of comprehend someone and this is pretty different. We're getting a bit deeper. Yeah, in the channel of water further around. Yeah. And one of the scientists explained that everything is so vertical, it's because they're trying to get their share of the food that's available in the water everything. So if everybody was stuck, the guys that was able to get it before another. So the competition for the fish. Just some fish.
How wide was the trawl overall?
3 minutes, I think. Yeah, octopus is right, like a gumbo one.
Oh wow.
Yeah, that's the code.
The sound from this must travel quite a ways, right?
You're probably all wondering what's coming. We've been here for 1,000 years, never been able to do that before.
They get a cylinder too.
Yeah, yeah. See how the bottom's changed too? The far more going than before.
Have you got a picture of how it looks after we've been through?
No. I don't think I'd like to see it. The thing would be that I think with the trawl you actually get the images in there. So it's not solid line. Oh, that was cheeky. Oh, they got like stands. They actually sit up on their fins. They look like a sort of cross-born beam. So they're up to about maybe 350, 400 watts. Wow. So the noise is much lower there, so it's sort of
Yeah.
just particularly low through it. And that little primer on the bottom there, it's called little pigs. They look a bit like a pig because of their shape. But they're actually transparent, so you can see all the innards inside them through the skin. This is a tub. As you can tell, sometimes the reason very often the identification is really based on electronics. The farm animals.
What location is this?
In 20 seconds now, it's the one. Everybody knows the data was inside. It's 1 So all the doors are in the outside of the so it's effectively the water control is carried and it's also the entry to the flame because the entry comes out if the height is taken up and you're not locally down below, you have to go by further to get it into the road in the doorway and the floor. That's the bulkhead, so it's also the bulkhead. So you put that through the door and the whole entry can be moved out with it. So that you get the way out. And you get it out to the door and ready to go up and the line of the hole. See, some of these flowers will have been done for us. You know, when you've done the rosters or something like that. And you see what they're doing it up. Or it could be just first part movement. So let's look at spruce stuff. We're looking at some photos of the project coming up in the Bunker Hills. And we're looking at that during the afternoon. And there was sort of like solid bedrock, but then there were layers of all these types of rocks with different geology that's in the He runs like the captain runs the ship, the bosun runs the deck, so he's in charge of the seamen.
So you just go to boats and regular operations now for 2 years?
Yeah. There you go. There it is back again.
Wow. That's awesome.
That chain in the front was like a tickler chain in case there was some big nasty rock poking up. So it would actually flip it up
pictures in
and
the
get
day.
it to go over the rock.
That's through to this, a little longer city.
So there you go. Marine science in an hour and a half.
At 1.6 kilometres, apart from rocks and rubbish, was there actually anything alive?
Yeah, it's subgroups everywhere in the ocean.
Didn't see anything.
No, didn't see nice big stuff.
Lots of stuff down there.
But that noise it all ran away.
Yeah, well, that's right. Would you go away if they're killing it? You'd sort of be.
800 metres looked like a forest. Or meadow is the difference.
Anyway, can we show our appreciation?